Hey there, welcome. I hope you remember in the last few videos we have been talking about the gas law, and just for your summary, so the first one was Boyle's law that said P1 V1 equals P2 V2. That means the product of pressure and the volume is same. Then we talked about the Charles law that said V1 upon T1 equals V2 upon T2. Now what we did later on, we combined them into one equation that's called combined gas equation. P1 V1 upon T1 equals P2 V2 upon T2. But until now we have not been talking about the third law, which we are going to do today, and then use all the three to derive what what chemists call as the ideal gas equation. Let me put it all here. So, what is the Avogadro law? The Avogadro law says that at constant temperature and pressure, so again remember here the T and P are constant, the volume occupied by gas is directly proportional to the number of moles, N. So, more moles, more is the volume. A pretty simple equation. Now, that means V1 upon N1 equals V2 upon N2. Simple, right? Now, you have to remember one thing. We did talk about standard molar volume a lot before when we were talking about stoichiometry. We said the standard molar volume of any ideal gas is 22.4 liters at STP. Now, I want to state one thing here. We have by far discussed three laws as of now, that is Boyle's, Charles, and Avogadro. All of these laws are applicable to ideal gases only, right? That means not all gases are ideal. That means they do not obey this relationship at all temperature and pressures. But the deviation at normal temperature and pressures, normal temperature and pressure simply means that pressure and temperatures that we generally work with gas laboratories or industries, right? So we say, or we group these relationships are obeyed by the ideal gases, right? In ideal scenarios. Now, we attempt to summarize the three gas laws that we have covered so far. Volume is inversely proportional to pressure. Volume is directly proportional to temperature. Volume is directly proportional to N. We kind of summarize all the three, right? So that comes out to be volume is directly proportional to N, T, and P. Now this has no restrictions. Now I want you to understand that for Boyle's law, we had a temperature as constant. For Charles' law, we again had pressure constant, and obviously the mass was constant too, right? For Avogadro law, what we do have is the temperature and pressure are constant, right? But when you combine this, there are no restrictions, right? So what we want is we can come up with P V equals nRT. Now we did change proportionality to an equality here. Whenever you change proportionality to an equality, you always bring in a constant. Now this constant, as you can imagine, is the gas constant, right? Now again, the usual symbols are the same. P is pressure, V is volume, N is number of moles, T is temperature in Kelvin. The gas constant is a little bit tricky because you have to use it according to the units of pressure and volume that you are using. So it can be used as 8.3144 or 0.0821. So when you're using in this one, you must use this unit, right? Let's try to solve a few problems, very simple in this one. Let me again give you a pause of 5 seconds so that you can pause the video right now and try to come up with the solution on your own. Here is the pause. I hope you have utilized this opportunity by now and you have already solved the problem. Now, let's try to solve it here. So, it's pretty simple. You have the grams of xenon, you have the volume, and you have 20 plus 273 Kelvin, that is 293 Kelvin at, remember this is your temperature, right. So, you have volume, you have temperature, you do not have N, and what is N? N is given mass. N is given mass by molecular mass, and now I am very sure you know the mass of xenon, which is 131.3, right. So, N comes to be about 0.411 mole. Now, we use our equation P V equals nRT, right. And what does that mean? That means pressure right now that we would be using is, we do not know, let it be like that. Volume that we are going to use is 1 liter equals N 0.411, just a second, yup, R, which we just understood, it is 0.0821, T, which we just calculate to be 293. So, if you calculate for P, you say it comes to be around 0.89 atm. Now, remember you brought atm here because of the R, the value, the unit of R was the same. Now, let us get a little bit better at this by solving one more question that would definitely help us. Now, calculate the volume. So, you do not know the volume of a gas filled with 4 moles, you know the N, of helium, you know the mass 4, atmospheric pressure, that is a P, temperature 30. So, 30 plus 273, that comes to be about 303 Kelvin, right. So, you have to again use the same. But again there is a slight of an issue, the pressure is given in torr. That means you must convert it into atm, atmospheric pressure, so that you can use it. So, first let us do that. So, P equals 748 times 1 by 760, because 1 atmospheric pressure has 760 torr, right. So, this comes to be about 0.984 atm. Now, we have N, that is okay, given mass, what is N? Given mass. So, remember, so N is very easy, given mass by molecular mass. So, that is 4 upon 4 equals 1. So, N is pretty easy. You already know the R, you already know have calculated the T. So, what you have to do is calculate the volume, right. So, volume is P V equals to nRT, that is the the equation. So, V is nRT upon P, that is 4 times 0.0821 times 303, that is our temperature, 0.984, that is our pressure. This comes to be around 101 liters. I hope this makes sense, and I hope this appears as easy to you as this sounds, right. So, if you haven't already checked out the previous past videos on the gas laws, do it, and I am very sure they would all help you a great deal.
We hope you like this video. Press subscribe, thumbs up, and stay geekly.